So how do we do this problem? Well, they kind of tell you in the problem that you need to differentiate this potential to find the components of Ex, Ey, and Ez of the dipole. So what does that mean? That means we have to take some derivatives. So to find Ex, E is the negative partial derivative, that's what that curly little d means, of the potential with respect to x. So what this partial thing means, this curly d, means that we're taking the derivative, but the only variable in the problem is going to be x. X is the only thing we treat as being a letter. Everything else, so this p, this epsilon naught, z, y, and z and y, are all going to be just kind of constants. We can treat them like they're numbers. So if I want to take the derivative of this, minus partial derivative with respect to x, again, those little curly things mean partial derivatives. I need to take this partial derivative of p over 4 pi epsilon naught times z, all divided by x squared plus y squared plus z squared, all of that raised to the 3/2. So this derivative seems gigantic, seems kind of complicated, but it's not too bad. In order to do this, I need to only have in mind that x is the only variable. So I need to use the quotient rule to take this partial derivative, or I can use the product rule if I imagine this as being rewritten as a product. So I'm gonna do that. I like the product rule a little bit more than the quotient rule. So to bring everything that's on the bottom up to the top, so this 3/2 to bring all that up top, I just raise this to negative 3/2. So this is going to look like the following: partial derivative with respect to x of p over 4 pi epsilon naught of z times, now all that stuff in the denominator gets pulled up to the top if we take this and raise it to the negative 3/2 power. And now I can take this derivative. If I want to do the product rule, I need to take the derivative of the first stuff times the derivative of the second stuff plus the second stuff times the derivative of the first. So the product rule, I imagine all of this is the first element, all of this is the second element. And if I want to take this derivative with respect to x, I can see that all the stuff that's in the first part has no x's in it. So it's just a constant as far as this derivative is concerned. So I can take the first, and I write that down, first element, 4 pi epsilon naught times z, times the derivative of the second piece. So the second piece has an x in it. So I need to take the derivative of this, and I can use the chain rule to do that. So I take that exponent, the negative 3/2 comes out front. I take everything that's in the parentheses, and that comes along with me. X squared plus y squared plus z squared. I raise this to the negative 3/2 minus 1, so that's the chain rule. Look it up if you don't remember it. We did this in Physics 1. And then I need to times this, multiply this by the derivative of whatever in the parentheses. But the derivative of the stuff in the parentheses is actually pretty easy. I only have to differentiate the things that have x's in them, because x is the only variable in my problem because I'm taking this partial derivative. So my x is the only variable. This y and this z are basically just numbers, and derivative of a number is 0. So I can take the derivative of the stuff that's inside of the parentheses. That derivative will be 2 times x. And then there we go. That's my derivative. So that's the first element times the derivative of the second element. Now for the product rule, I need to do plus the second element, which would be x squared plus y squared plus z squared, all of that raised to the negative 3/2, times the derivative of the first element. So if I look at this first piece, I don't see any x's there. So as far as this derivative is concerned, again, because it's a partial derivative, I only care about things that have x's in them. Since this has no x, as far as this partial derivative is concerned, this is just a number. So the derivative of a number is 0. And this whole second part cancels out. And this is our final answer. If you do a little bit of thinking, you can realize that the This is going to be equal to EX. If I think about it a little bit, and you'll take a look at this on your own, and you should be able to see that EY is going to be the exact same thing, more or less. 4 pi p over 4 pi epsilon naught times z times negative 3 halves times x squared plus y squared plus z squared, all to the negative 5 halves, and that's going to be multiplied by 2 times y. And you can think about that, and you can actually take this derivative to see why that's the case. Now, EZ is going to a little bit trickier. So EZ, we have p, we need to take the derivative with respect to z of this p over 4 pi epsilon naught times z times x squared plus y squared plus z squared, all to the negative 3 halves. So this same concept that let us get our EY very quickly, we can get part of EZ very quickly. So we can just repeat this, p over 4 pi epsilon naught times z to the negative 3 halves times x squared plus y squared plus z squared to the negative 5 halves. And this is going to be times 2z. Again, go back, take this derivative, make sure that you can understand where that comes from. But now, whereas with respect to the x and with respect to the y, we didn't have to do anything with this first element, now I have to do something with this. I have to include this derivative in here because there's a z right there. So I need to take the derivative of all of this. But this p over 4 pi epsilon naught, that's just basically a constant that's out in front of that z. So if I take this derivative, I should be able to see that that derivative is p over 4 pi epsilon naught. So now I have the first times the derivative of the second. So that's the first element times the derivative of the second element, plus the second element, which is x squared plus y squared plus z squared, all to the negative 3 halves, times the derivative of the first. So I need to take this derivative. It's all of this coefficients out front multiplied by z. So that derivative, if I take that derivative, is p over 4 pi epsilon naught. It's essentially, what's the derivative of 5z? Derivative of 5z is 5. So here, the p over 4 pi epsilon naught is basically more or less serving the same purpose as that 5. It's just a constant that you're multiplying by. So then this is my derivative, my answer for EZ.